Hello. Okay, we started for Tech 2 today. Okay. Okay, so you get that, you get input A, B. I want to know what the formula for the output.
Not AB?
Okay, you can say A and they go to the inverting. So they could be not A, right? B go inverting, they could be not B. So basically, formula could be A and B not. And that will be equal not A or not B. So this is the formula you need to memorize. Okay? So if I say A is 0, what output?
One.
They must be 1. This will be don't care, right? Okay? And now, AB, what Y equal? What Y equal for that one?
Not A and not B.
Yeah, not A or not B. How can we get that? I can show you. A, that means right here. Not A. B means not B. And this is the OR gate. So that's why. Not A or not B. So what is the name for this gate?
Or
It's not.
NOR.
Oh, no. No. Oh.
NOR is wrong.
No.
They will be
Man.
NAND. The first one you can get that also the NAND.
Man.
Both the gate will be the NAND gate. One they using AND, one they using or they get inverted in the back. But they're working identical. Okay? Either one, there will be a NAND. And a NAND, one input 0, output must be 1.
Yes.
Yeah, any question?
Um,
Okay?
This one is
That will be what gate?
um,
And
and
And.
and
Okay? If you get a 0 here, what out?
0.
0. Right?
Yes.
Okay. Now, if you get a 1 here, then you cannot tell what the output, right?
correct.
You need that if you get a 1 in here, then output to be a 1. Okay? So, if I change that to be 0, what output?
0.
0.
0. So that's what they call a logic gate.
Oh, this one logic gate.
Logic gate means you change the input, output will be changing followed. Okay? That's for the logic. They can get AND OR, NAND NOR, inclusive OR, inclusive NOR, inverter. That means you change input, output will be changing. Okay? And then today we will be talking about the flip-flop. Now, by definition, this is a flip-flop. I say F and F. They can get one input, two input, or more. That will be input. However, output they get only two. One we call a Q. One we call a not Q. Okay? And they must be opposite. Okay? That is the definition. Flip-flop, they can get one input or two or more. However, output, they get only two. One we call a Q. The other one we call a not Q. They must be opposite. If they're not opposite, that means they're not a flip-flop. Okay? So if you get a 1 here, then this one must be 0. Or you get Q equal 0, not Q must equal 1.
Opposite.
That's the definition for the flip-flop. You get that? Okay. So now I go in back with my desktop. Okay, so now you can see latch and the flip-flop. Okay, the first thing is basic, a device that has one or more input, but only two output. And they must be complement of each other. So the first one is this is the latch, active high input, add and R. Add mean set, R mean reset. Okay? When I say set flip-flop, that means Q equal to 1. If I say the reset flip-flop or clear, that means Q equal 0. See, I'm not talking about not Q. You know Q, you know not Q. Okay? And one, they using the NOR gate. And the other one, they using the NAND gate. Okay? And this one, they get a true symbol for the active high and the active low. Set and reset. Now, looking on it for the NAND. If I get S equals 0, then what Q?
One.
If S equals 0, what the Q?
One.
Perfect. Q must be 1. The thing I did is active low. That means 0, you set the flip-flop. Same thing. Active low. 0 here, you want to reset the flip-flop. Okay? If I say I get a reset 0 here, and you understand a Q must be 0. Now, go back to that guy. No. Active high. Okay? If S equal 0 or equal 1. So my question is, if S equal 1, what happened?
1 and 1 is
That means you want to set, right? Active high. 1 set, okay? So when you want to set, what that means? Q must be equal to 1. Okay? Same thing. On that one, if R equal to 1, Q must be 0. Let's try to learn how to deal with the active high or active low. Now, if you're looking on the symbol here, you see, on that one, basically inside they will be the NAND gate inside here. On the other one, inside they will be the NOR gate inside here. So by looking into this active here, if I given to you S here equals 0, then you know for sure Q must be 1.
Mr. Pham,
Yeah,
can you turn your pointer on? Because every time you say here or here, I don't see which one you're referring to.
you see on my pointer here?
No, don't see anything.
The whole time you've been talking, Mr. Pham, your pointer has not been on, so they don't know what you're talking about.
Yeah. So I'm kind of confused.
Oh, let's see.
From the very beginning.
Okay, let's see. Why they not so? Okay. Now you see my pointer?
No pointer.
Uh-uh. How come? Let's see. I try to share on the other side. Okay,
Yeah, see the pointer now.
now I try to see. You see my pointer?
Yes.
Yeah.
Thank you.
How come on the other side they not? Okay, anyway. This is the NOR flip-flop and this will be the NAND.
On my hand. Oops, sorry.
What happened?
Kumi, what happened, Kumi?
Sorry.
Okay. We understand in the flip-flop they get one or two or more input, but they get only two output. And those output they must be opposite. Q1 and not Q have to be 0. Q0 not Q have to be 1. They cannot be the same. Okay? And the first two flip-flop, you can see that will be the NOR. That means they're using the NOR gate to build. This is the NAND. They're using the NAND gate to build. Okay? Now, when you say set flip-flop, you must understand Q must be equal 1. When you say reset flip-flop, then output Q must be 0. Okay? When they say active low, get the bar over. That means 0 you set. Okay? So I know for sure if I get 0 here, then I know Q must be 1. Okay? Reset, if I get a 0 here, Q must be 0. And now this NOR flip-flop active high. Do not see the bar over. If you say set equal to 1, for sure you know Q must be 1. If you say reset equal to 1, Q must be 0. Okay? But normally you can see the symbol for each one. For this symbol here, if I say R equal 0, R means reset, then you know Q must be 0. Not Q will be a 1. Okay? However, what happened is you get a 0 here and 0 here. What happened? If you get a 0 here, then Q must be 1. Right? We don't care on the input in the back here. Okay? R equal 0. What happened to the output?
Is that an illegal operation?
Now, my question is, for this flip-flop here, I put a 0 here. What Q?
1.
They must be 1. They don't care on this one. This is a feedback. They don't care. No matter what here, at equal 0, Q must be 1. That is a NAND. Same thing. R equal 0. What happened?
Q come back to low.
No, it's
0.
1.
1.
Not Q must be 1. The thing is,
But Q
NAND.
is 0.
This is just a NAND. I'm not talking about Q. I'm
Q
just
come back
talking
low.
about NAND gate. At here 0, Q here must be 1. Correct?
Correct.
Yes.
R0 here.
Q come back to 0.
Now we don't talking about Q. I'm talking about the NAND.
Mhm.
If you get a 0 here, what happened to not Q?
1.
1.
They must be 1.
But the problem is Q and not Q both can't be 1 at the same time.
Right. That's what
Exactly.
I'm saying. Isn't that illegal? Can you take? Isn't that
Illegal.
not possible?
That's illegal.
Okay, thank you.
we already said the flip-flop to output, they must be opposite. Okay,
Right.
so for this one here, if you get a 0 here and 0 here, they not working like the flip-flop. Okay. Now, normally in the truth table, okay, for that guy here, okay, if you get a 1 here, 1 here, okay, so maybe I need to share on my iPad so I can help you to understand.
Hey, Mr. Pham, while you're doing that, one of the things you're trying to show us then is that the input on the one that says active low, they cannot be, the inputs cannot be 0 at the same time, but they can be 1 at the same time.
Perfect. Okay, let me see again. Okay, step now on that one. Now I try to repeat again, okay? So basically you get 0 here, 0 here, okay? And you already know zero here, and this is the NAND. This is the NAND gate. Then no matter what, output must be 1, right?
Yes.
Mhm.
And
Yeah.
0 here, I don't care the input here. Output must be 1. Okay? So both 0, they not working like the flip-flop.
Call the police because that's illegal.
Right. So that's why in the truth table, what they said right here, invalid condition. What that mean to you? That will be telling you one thing. When you're working with this kind of the flip-flop here, never connect both to 0. Okay? You see that? The thing is that will be illegal. Okay, so now you understand. Okay, so normally for the flip-flop, you get the table telling you when you get the input, what the output. Okay. Now,
Mr. Pham,
yeah,
what does the NC stand for?
what?
What does the NC stand for? Go back to the diagram, the one you were showing.
Yeah.
You like the number 1, 1, and then there's NC, NC. What does that mean?
Now
No
what?
change.
No change.
Oh, okay.
No,
All right, thank you.
okay. Now,
Alright.
what that mean no change? What that mean? How much you understand? How about no change? Okay.
If it,
Now, you see that one. I get 0 here. I get 1 here. What output give?
0, 1.
Q is 1.
Give equal 1. And not give equal
0.
0.
So you see one, they fit it back here. 1 and 1 is 0. 0 go back here. 0, 0 is 1. It's working okay. Okay, now. Okay. Now I change 0 here. Okay. Change to 1. If you're looking into the table, 1 and 1, 1 and 1, they say no change. Right?
Yes.
No change mean it was 1. Then now still be
1.
1. That means no change.
And that's based on the whatever clock transition that
Now
The-
the clock here
no?
on the input condition.
But the output will usually change with the clock transition, no?
Now we don't have a clock here.
Okay.
Okay. If I said at the beginning, I say add 0, 1 and Q equal 1 and not Q equal 0. Then I say I can add from 0 to 1 and 1 and 1. You're looking into here on the table, they say no change. Okay? No change mean it was 1. Now they still be 1. That means no change. It was 0. Now they still be 0. You get that? Understand for the no change, right? Any question on that?
Yes, sir. Marcelo here, Mr. Pham. One question. Could you please provide some context where these flip-flop are used?
So you want to get a definition?
I guess no. Just an example where these devices are used, in which portion of the circuit or for what are used.
Okay, right now you learn the subject for the flip-flop. Then you have to not be understand the flip-flop first before you want to do something else. I'm already telling you, the flip-flop is a device. They can get one or more inputs. However, output only 2 output. One Q, one not Q, and they must be opposite. That's a definition. And now they can build the flip-flop using either NAND gate or the NOR gate. Okay?
The one on the left and the one on the right is work the same.
No, they working a different.
Oh.
Okay? The thing they did will be active high.
Mhm.
This will be active high. This active low. First thing, how do I know?
Active low has a bubble and active high does not have a bubble.
Exactly. You see R here, no bubble. Okay, this one you get a bubble. So that's why I know they will be active high or active low. Now, when we say set flip-flop,
Set flip-flop.
that means Q equal what? If you say reset flip-flop, that means Q equal 0. Okay?
Reset.
Now, if I get R here equal 0, what Q?
One.
Q is 0.
0.
R means reset.
Only set.
Reset or clear, the same. That means Q must be 0. Okay? The thing is when they get a bar active low, means 0, they reset.
Okay, okay.
Or set here, they get a bar over. That means 0, you want to set.
Set.
Okay? Now, on this one here,
Set 0.
if I say R equal to 1, what Q?
Reset.
0.
Perfect. The thing is active high. That means 1, you want to reset. 0 means nothing. Okay? So try to understand active high or active low. Any question about that thing? Now, also by the way, I can talking about the next state. And the present state. Okay? So if you get a 0 here, what Q?
1.
Q equal to 1. Okay? So when Q already equal to 1, that's what you're talking about, the present. Right now, Q equal 1. Okay? So, if I am going to change the input, okay, for example, I change that to 1 and change that to 0, okay, and the output will be changing. That's what we're talking about, the night, okay. The state means logic 1 or logic 0 of the Q. So the next state, what happened? That means you are going to changing the input. What will be happen? That will be the night. Even they only Q, but they can be present and they can be the night. Present, that means they're already there. Next means they are going to be when you try to changing the input, okay? Now, if you try to understand, you can do this, you can see this one, how they working. That means you understand. They say if S and R, the waveform here, they given you this the waveform. S and R, okay? That means 1 here, 0 here, okay, and 1 here. apply to input of the large. That means they apply to this guy. Okay? And they want to draw the Q. Okay? We don't care not Q. You know Q. You know not Q. Okay? And also, I already gave you the truth table. Okay? S equals 0, 0, they say not allowed. That means illegal. That force both the output to be a 1. So never happen. S0, R1, then Q equals 1, not Q equals 0. S equals 1, R equals 0. Okay? And output Q 0 and 1. And if you get a 1, 1, they say no check. Okay? And also in this one, they say assume Q initially will be low. So no matter what, I know Q will have to be here, 0 at the beginning. The thing is they say Q initially 0. Okay? So now, if I want to draw for the output Q, I need to know S, I need to know R. So the first one here, you get a 0 here, and you get a 1 here. What Q?
1.
1.
If you want to know, looking into the table, right here,
1.
It's a whole table of truth.
R1, Q equals 1. So that's why Q will be go to 1. Okay? Q will go to the 1. So, and next one, S equals 1.
1.
Q, R equals 0. What Q?
0.
0.
0. You see that? They go to 0 here. Okay? And the next one, 0 here, 1 here.
1.
1.
Okay? So basically, they have to go that one here. Then you get a 1. And the next one, you get a 1 here
0 here.
and 1 here. What happened?
No change.
No change. Okay. That means it was 1. Now they still be.
1.
That means no change. Okay. And the next one.
1.
1 here, 0 here,
0.
0. And they will be 0 up to here. However, that one will be 1, 1.
No change.
No change, they keep 0. Okay? And go to the next one. 0, 1.
0.
0.
They keep 0. And like 1 and 1.
No change.
Okay.
No change, 0. Okay, 0, 1.
1.
1.
1. Then they be no
No change.
right? 1. And 0 here, they
1.
1.
When
No
it's
one
1,
match.
1, no change, should we put 0 or leave it blank?
I try again.
Okay.
Make sure you understand that thing.
Yes, please.
Okay, right now, you see up to this point.
Yes. Yes.
And you get 1, right?
Yes.
So now you go to the next one to get a 1.
1 and 1. Uh-huh.
No change.
No
Right?
change. Yes.
No change means it was 1 here.
And still 1.
They still 1.
Okay.
That
Okay.
means no change.
Thank you very much. Next one is 0, 1. 0, 1 is 1.
And then after that, you get a 1 and a 1.
Yeah.
Yes. And no change is 1.
Correct.
Okay. Got it. Thank you. Thank you.
Yeah, you guys must understand. I only need you to understand.
Yep. Mm, mm. Got it. Got it.
You say it's the big one or small one? Maybe small one.
You see you. Yes,
Okay.
big one.
Yeah. Now I go back to that one. The thing is, I need that one. Okay. So you already done for this example here.
Yes, sir.
Okay. Now the next one will be the talking about the gate. Okay. The gate set reset latch. Now, if you see this guy, can you see my pointer here?
Yes.
Okay. So this time you can see my pointer. I want to try again to see if I using that thing. Can you see it?
Yes.
My pointer.
Color.
Yeah.
The green color. Upper
Yes,
color.
yes, we can see it, Mr. Pham. We can see it.
Okay, you see now.
Yes.
Okay, good. Now, what the flip-flop here? Get two. One will be the NOR gate. One will be the NAND gate. Which one?
Left side or no? Negative right side.
This, you can look in the previous page.
Right is the
I
NAND gate.
That's the
left-
NAND. Okay? This is the NAND. If you get a 1 here and a 1 here, what happened?
1, 1 is not change.
No change. Okay? If you get a 0 here, then you know you have to be a 1.
1. Mhm.
Okay, now they adding 2 more NAND gates here. So basically they try to using what they call AND enable to control the output flip-flop here. Now, if I get the enable equal 0, if I get a 0 here, what I get at here?
1.
1. We don't care about it.
Oh,
0 here. Also, I get it here will be
1.
1. That means the output will be no change. So in this case, 0 enable here, then no matter what you can add or you can add, output cannot be changing. Okay? So basically enable here, control that output. If you want then apply add and R, and output will be changing, then enable must be 1. So if I'm looking on the symbol right here, if I get an enable equal 0, no matter what S in equal, I equal, output have to be no change. If you want the output to be changing, enable must be 1. Okay, now this one, try to understand on this thing here. They say they want output Q. You get S and R and enable. Also, they say the output SR initially reset. That means no matter what at the beginning, okay, before you enable go to 1, Q will be 0. So that will be 0. Okay. When you get a Q equal 0, go to the next one. What S equal?
1.
1. R equal
0.
Or 0.
Enable equal 1.
1.
Okay. So that's why Q equal 1. Okay. Q equal 1. And here S and R will be changing. However, output cannot be changed. Why? The thing is enable now go to 0. Okay? That means output Q and not Q only change when enable equal to 1. If enable equal to 0, no matter what input changing, output still be no change. Okay? That is for the enable gate. They control by enable. Okay, now summary. You can get input S, you can get input R. By looking into the truth table here, you know what Q. However, that only apply when the enable equal to 1. If enable equal 0, you don't have to see the truth table. Output have to be no change. Okay? So basically, the flip-flop will be controlled by the enable. Okay? Now, you can do for me this one. Draw Q. This is a my prepared, so that's why must be much better than what in the book. The other one I take from the book. It's not really good. So in order to draw the output of the Q, not Q, look what S equal, what R equal. Then looking into the table here, they tell you what Q. Only thing, make sure you understand a no change. Okay? So, can you draw it for me? I want to know. When you done it, let me know.
Okay.
Want to see how many people can get the right answer. If S equal 1, R equal to 0, what Q equal?
1.
1. Okay? Just following the truth table.
Okay. 0, 0. Not change.
Whoever done, let me know.
0, 1. 0, 1, 0. change. 0, 2, 1, 2.
Done it?
I ran out of paper, but there you go.
What do you mean now paper? If you get a print out, you get the print, you get the print out the handout cannot be done out paper.
Oh, you're right. I did it on a blank piece of paper, but I
Okay.
sector 19. I did the rest.
Okay. Okay, let's see. Uh-oh. Okay, let's see. Okay, now that is how they look like. If you get a different, go ahead and ask it. T0, T1, T2, 3, 4, 5, 6, 7, 8, 9. Which one is wrong?
Okay, high, low. Low, high. Low, low. No change, it's still high. Low, high. Should give you a low. Low, low. No change, it's still be low. High. Low, should be high. Low, low. Still be high. Low, high.
No change.
Make sure you guys understand every lecture will be recorded. So if you can go to the YouTube, you can look in again. That's why you can see the output. Make sure you get the right output. Anything cannot do it.
Can you repeat that, Mr. Pham?
What?
Can you repeat the S and R, please? The top one?
Okay. S and R here, right?
Yes.
Okay, so basically you can get the truth table here, right?
Yes.
Okay, active high.
Mm-hmm.
You get a 1 here,
0
0
bottom.
here. So they will be T0, they will be 1.
Oh, okay.
The table will tell you. Add 1, R0, Q1.
Uh-huh.
Okay, they will be 1 up to here,
Okay.
T0.
1 0 1 is 0.
Now, what happened? T1, what add, what R? At T1, what add equal?
S goes low, R is low, so there's no change.
No change, correct. That means it was 1 here, they have to be 1.
Then at T2, R goes high and S is low, so
Right.
Q is 0.
Right, perfect. Just look at the table. Q0. And this one will be a 0 and 0. No,
No change
No
again.
change.
0.
No
And
change.
the next one, T4. 1
4, 1, 0, 1.
and 0, 0, no. Yeah.
1 0 1 1 0 1.
Final change.
Okay, final change. Perfect. Next one, 0, 1.
0 1 1.
Come on.
0, 1, and 0.
1, 0.
0. Q is
0,
0.
1, 0.
Hey,
0 1 0 1 0.
then next, 7.
0 and 0. No change.
0, no change.
Okay. Okay, 8. 1, 0.
1, 0, 1.
1.
1. Then 0, 1.
0, 1,
0.
0.
Okay.
Yeah.
You're all technicians.
Aha.
I need more
I did
techno.
one.
Ay.
Make sure they given to you. Q initially low. That means at the beginning, Q must be low. In order to draw it again, I'm telling you, looking for S, looking for R, and go to the truth table. They will be telling you what Q. They can be 1 or 0 or no change.
So Q starts out high because 1, 1 is no change.
No change, but you don't know. No change, but you don't know what it was. So that's why they given you right here. Q initially low. That means Q here have to be 0.
0.
Okay? That's at the beginning. At the one, when I just get out the university interview job, they asking me, I couldn't draw it. The thing is, really, I'm not understand.
1 1.
So that's why they send me back to the school.
They send you back to sit with me forever, right, Mr. Graham?
That's why I really want you to understand. Okay? You go to college, you go university, you're doing the same thing. The very basic thing must be done. Whoever done, let me know. And I can tell you my answer.
I'm done, Mr. Pham.
You done. Hey,
Sure.
you're really good. I believe you can get the right one.
Thank you.
When you get the key thing how to do, then not a big deal. Okay. If you get anything wrong with that, or maybe I'm wrong, just let me know.
0, yes.
Perfect. You're pretty good, Mr. Pham.
Kumi,
Yes,
you can see this is your second time, right?
yeah.
Second time maybe can be understand. The first
Yes,
time, not student can understand right away.
me too. I still don't understand, Mr. Pham.
Okay, good.
Okay, good. Okay, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1. Yes.
Get it?
Yes.
Okay, the thing is, the key point for this class will be teach you how to working, troubleshooting. But the basic you don't know, no way I can teach you. Okay, now you, let's see, that S and R. Do it, go ahead, calculate it.
And,
Assume Q will be low at the beginning.
Q output.
Who done it? It get have a node to table. However, you can look into the bubble here, active load. That equals 0, Q must be 1. I equals 0, Q must be 0. Okay? If you get both 1 and 1, they will be no check. That is the output.
Zero, one, 0, 0. 1, 1, no change.
Make sure S1, R1 will be no change. Done. Did your guy done it?
I'm good. Thank you. Yes. Got it.
Okay. Okay, that one we already done. Okay, now they want you to draw that one. Make sure they say initially they will be reset. That means at the beginning they will be 0. And only when enable equal to 1, then you can looking into S and R to get Q. If enable 0 here, Q will be no change.
Yes. Enable.
Okay, if you want to know what Q equal, only S enable equal to 1. You look it up, S equal 1, R equal 0. Okay, and this give you the symbol right here, active high. S equal 1, Q have to be 1. R equal 1, Q have to be 0. But when enable equal 0, you don't need to looking into S and R. The thing is Q have to be no change. Okay, that is the output, how they look like. If you've done it, let me know.
Not yet.
Okay, just let me know when you're done.
Thank you. Q, Q, Q.
Mr. Farm,
Yeah,
when and we apply and by high by one, Q is chain.
right.
That's right.
Only change when the enable one.
Yeah, thank you.
If enable is 0, no matter what SR changing, but still have to be no change. That's what they control by enable. Done it?
Yes.
Okay. Now, they get the D latch. Same thing. Only thing is that will be inside the D. Okay? They get only one input. Basically, D equal 1, Q equal 1. D equal 0, Q equal 0. However, they control by enable. Okay? If enable equal to 1, Q equal to D. If enable equal 0, Q will be no change. And now you can draw that one. Initially, they say reset. That means at the beginning, they will be reset to 0. And when you're looking at enable equal to 1, you want to know Q. You're looking for D. D1, Q1. Okay? And after that, no matter what Q changing, but enable 0, Q will be no change.
Mr. Pham, can I ask a question?
Yeah.
Is it fair to say that a latch is controlled by the enable, whereas a flip-flop is controlled by the circuit clock?
Right.
Okay, thank you.
Two, 1, 2, 3, 4, 5, 8, 9.
That one much easier. That is the output.
Could you tell again the concern of the D and N?
Okay. On this circuitry here, what I'm saying here, if enable equal to 1, Q equal to D. If enable equal 0, no matter what, Q must be no change.
Thank you.
It's more easier than the S and R. You have to looking in two input. That one you're looking on only one D.
Q.
Have you guys done it?
1 minute, please. Yes, finish. Thank you.
Okay. Now, we're talking about for this gate. However, we're adding two more input. One they wanna preset PRE. One will be clear. Now, what happened? When the preset equals 0, then Q must be 1. They don't care about gate, they don't care about D. Same thing. When the clear equals 0, Q must be 0. Okay? And they don't care what D equals, what gate equals. This is a control. Q and not Q. Why we can get those two input for any flip-flop? Basically, inside the computer, they controlled by the clock. Okay? And sometimes engineer want to set the output Q at logical 1. Then they just put the preset 0. Then they don't care about anything input here. Q must be 1. Or they want to reset the output, they can put the clear to 0 and go Q must be 0 right away. Okay, so now on this drawing diagram here, preset already connect to 1. So we don't care. Okay, the thing is preset and a clear cannot be connected at the same time. Okay, to 0. So at the beginning, you see clear equal 0 right here. So what Q equal?
1.
0.
0.
0.
Clear equal 0. Clear, same thing, reset. Then Q have to be 0. Okay? And after that, you can get equal 0. Okay? D equal to 1. So D equal to 1, that's not telling you output will be. The thing is get 0, that's telling you output will be no change. Output only equal to D with the gate equal to 1.
So gate basically is enable.
Right? Gate
Okay.
enable, same thing. You're only looking into the enable of the gate at the 1. Then Q equal to D. If gate equal 0, there will be no change. That's it. That is the output.
In this diagram, why they use the clear? What for? We have gate. We follow the D. We have the output Q.
Okay.
Why we use clear more?
I try to explain to you. From now on, most of the flip-flop must be got two input, preset PRE, and the clear. That override everything. What that mean? Preset, you see the bubble. That means 0. Q must be 1 right away. Clear is 0. Q must be 0 right away.
Was there active high input?
That active high, that means they have to be a 1. No bubble. However, clear and the preset cannot be 0 at the same. If you get a preset 0, clear 0, flip-flop don't know what to do. One forcing Q to be a 1, one forcing Q to be a 0. Okay, so that never happened. If you want Q equal to D, then the clear and the preset must be 1. Okay, on this diagram here, preset they tie to 1. Okay, so cannot be change anything. So basically depend on the clear. At the beginning, they say clear 0 right here. And I know for sure Q must be 0. Okay, Q will be 0 right here. However, after that, clear go to 1. That's okay now. But the gate still be 0. Then Q still be no change. Now, at this point right here, gate is 1. So Q equal to D. Whatever D equal will be the same as the output here. They just copy from here to that output here. Then gate now 0. So from here to here, output will be no change. It was 0 here. Now they still be 0 up to this point. Until gate go back 1. Then copy D to the output here.
They give it clear for us to know that the initially of Q is 0.
Right.
Clear 0.
That's what they want.
That is the purpose. Yeah.
Yeah, that's what they give it to you. So they don't have to be initially Q is 0.
All right. Thank you.
Remember, gate equal to 1. Copy whatever D to Q. Copy exactly. However, gate equal 0. So Q is 0 right here. They still have to be 0. They no change up until the next one. Okay. Okay, that one. Basically, now we're talking about the flip-flop. The flip-flop, the flip-flop. The flip-flop, you don't have any formula. Only Q equal to D. When the clock here going from 0 to 1. Transition. Okay? So that's a very simple D. When you get a bubble here, that means Q equal to D when the clock going from 1 to 0. Negative. This is a positive going transition. This will be a negative going transition. Okay. The same with the JK flip-flop. You can calculate the Q equal to whatever, depend on the truth table. However, that only when the clock going 0 to 1 or the clock going to 0. Okay. Now, a little more detail here. Positive at trigger D. Okay. So basically, Q will be equal to D when the clock going 0 to 1 only. That one is transition. So if you want to know Q, you know to know D. However, you have to understand it only equal to D when the clock going 0 to 1. Okay, if you're looking at the table here, D0, Q will be 0 if you see the clock going 0 to 1. D equal to 1. Q equal to 1 if the clock going 0 to 1. Okay? Without the clock going 0 to 1, Q have to be no change. Try one thing here. Okay, I try to explain to you here. Now, they given the clock here. Okay, they given to D here. And on this one, they say flip-flop reset. So that's why Q0. Okay, so when the clock going 0 to 1, you want to know Q, you need to know D. D equal to 1. So Q will be equal to 1 until next clock transition. During this time here, D can be changing, Q cannot. So at this next transition here, you want to know Q, you need to know D. D0. So that's why Q goes to 0. And have to be 0 up to the next transition. Q1, D1. So Q will be 1 to next. D0. Now Q will be 0. Okay, everything will be explained to you in here for preset and the clear. Okay, you can see the flip-flop. Now they get 1, 2, 3, 4 for input. Okay, in here they said synchronous input, preset and clear, active low. Okay, you see the bubble. And the synchronous input D and the clock. That means D and the clock will be synchronized. Okay? Q only equal D if the clock going 0 to 1. They must get both in order to get Q. That's why they call synchronous input. Okay, total output Q and not Q, always opposite. Now, they explain to you here. A synchronous operation. If preset 0, Q have to be 1. Don't care anything other inputs. If a clear equal 0, Q have to be 0. Same thing. Don't care any other. Preset and clear cannot be 0 at the same time. Okay, The thing again, I telling you, inside circuitry, everything controlled by the clock. Okay. However, sometimes I want to set Q at a logic 1. I don't care the clock. Then I have to using preset. Preset low, Q must be 1. Or if I want Q to be 0, then I have to set the clear here to 0, then Q have to be a 0. Okay? And synchronous operation, preset and clear have to be 1. Q equal D when the clock going from 0 to 1 transition. Without the clock transition, Q will be no change. You have to read that. Okay, we try finish that one and we'll be done for today. Whoever can draw that one, you really understand. At the beginning, you want to know Q. You're looking on at, that means SD, preset, or RD, clear. On a different manufacturer, they're using SD, that means preset. RD means clear. If I'm looking on that one, I know SD equals 0 at the beginning. Q must be 1. That's what little thing I can help you.
All the way up to the transition.
Right, exactly. They have to be 1 up to the fourth transition here. Okay? Q only equal to D at the transition here. Without transition, Q cannot be changed. However, but looking into SD, RD, preset or clear. Whenever they go low, Q must be followed. If you can draw that one like I did it, then you really understand. Otherwise, next time still have to be exercise. Okay, whoever done, let me know. Understanding take you a few minutes to draw it. The thing is, this one no formula. Q equal to D when the clock going 0 to 1.
Q equal to D. Clock.
Preset 0, Q must be 1. Clear 0, Q must be 0.
Mr. Fan,
Yeah.
my problem with the circuit, a really circuit with many abbreviation letter. Could you sometimes you sum up the abbreviation of the letter in the circuit? I confusing with
No, no.
that many
Fine.
applications.
different. If you understand it first, then I can tell you your application. We don't want to get more confusing. This is a very simple thing. You must be understand. If I gave it to you on the explanation, you don't understand the explanation, let me know. However, after that, you're able to draw that one first. Don't worry about the application.
No. I mean it abbreviation. That is a smaller letter. A letter in the circuit, in the
What you
interest circuit.
mean?
It have too much letter. Abbreviation.
Yeah, what that mean?
That is sometimes they not write the reset. They use R something, only R letter, upper letter.
What
or
I
something.
will get to you. Different manufacturer, they're using different name. Sometimes they're using SD. Sometimes they're using preset.
That's my problem when
Okay.
I'm working in
That's
the relay circuit.
Yeah. In this one from different manufacturer, S means set, D means D flip-flop. RD means clear. D means for D flip-flop. R means reset. S means set. It's already telling you. Set means Q must be 1.
Yes. That is a symbol letter. I know, but sometimes I get a very strange letter. I don't know what's the meaning of that gate, that input.
Yeah, normally if you under the D flip-flop, then you can recognize easy for the input D, the clock, Q and not Q. And the other two input, they must be, one will be set, one maybe have to be reset. They can use in different name, but the purpose will be the same. You cannot get
Okay,
more
thank you.
input in the D. And this D flip-flop, to know the part number will be 74 LS 74. On the NAND flip-flop, NOR flip-flop, you don't have any part number. You get only D 74 74. And you can get another one will be JK in commercial. Not NAND, not NOR.
Okay, thank you.
You get that?
Yeah, thank you.
That they look like. You get any different, let me know.
I'm great, not even close.
Okay, now, at the beginning, Z equals 0. Q must be
1.
1.
Okay.
They must be 1 until clock going 0 to 1.
1.
So the clock going 0 to 1, you want to know Q, you must know D. What D?
0, 1. D is 0.
0. So that's why Q equals 0. Right?
Yes.
They will be 0 to the next clock here. See that? Okay. So at the next clock, you want to know Q. You want to know D. What D?
1.
1. By here. So they supposed to be a 1 up to the next
Up
clock.
to next
However,
Next clock.
no. However, they supposed to from here to here, but this guy reset going
Low.
low. So Q must be low right away.
And it's low all the way up to the next transition.
Exactly. They have to load up to the next transition. And Q equal 1. So that's why Q equal D equal 1. Q equal 1 up to the next. The thing is now preset and clear both high. We don't care. So when you get into the clock transition here, D0, Q go 0. Go next transition, Q D1, Q1.
Mr. Pham, next time can you use your iPad, please?
Using iPad,
Yes, when you do on your iPad, it's more understandable, it's more clear.
okay. Now, you know why? The thing is, sometimes I want you to do,
Yeah.
okay? If I using iPad and they already show the answer, and not until I get the key for Microsoft Office
Uh-huh.
to my iPad,
Okay.
then I can do. Hopefully, next time I can do it.
Yes, please.
I understand using iPad easy for explain to you guys.
Yes.
Okay?
Hey, Mr. Pham, can you go back like about 4 screens? There was something I wanted to copy down.
You mean the full screen?
Go back like four pages.
One page. Now, one page. 2 page. Tell me when you want.
Okay. Yeah, right there.
Okay?
Yeah, right there.
Make sure if you
Okay, I got it. Thank you.
Yeah, make sure if you're still confusing, need to look in to the YouTube, okay? That will be giving you more time. You're able to copy whatever you need. Okay, so that's it. We'll see you guys next week.
Thank you.
Good night, Mr. Pham.
Good night, everyone.
Thank you. Good
Good
night.
night.
See you tomorrow at 5, Mr. Pham.
Thank you.
Thank you, Mr.